Hey mathematicians, let's do our homework. Okay, so today we're talking about graphs and tables and equations all together. Exciting stuff. So this graph we're looking at here, we can look from the title, but we can also read in the problem. The graph shows the amount of calories that Jada burns when she climbs up the stairs. Because, lots of stairs equals quite the workout. So X is going to represent the flights of stairs. That's like how many levels of stairs. If you go up one floor, that's usually one flight. 2 floors, 2 flights. So on our X-axis, even though it says F right here, because we're talking about flights of stairs, that's still our X, or independent axis. And our Y is representing the number of calories burned. Our Y always goes on the vertical dependent axis. They're calling it C here, probably because we're going to do like an F and a C when we write the equation, but you could also call these still the X and the Y axis. Create a table using the ordered pair from the graph. So I'm going to do my table this way just so that there's room. On the top, you always put the independent variable, so flights of stairs, which we're calling F. And at the bottom, you put the dependent variable, calories burned, calling that C, and you need the titles of your table. Now the ordered pairs are the lines right at the corner of each square, and it's so nice that this line that is graphed goes directly through each corner. If it skipped one, we'd have to kind of skip over it because we don't want to eyeball and guess. But if the line that you graph, the dark, bold black line, crosses through the corners of each of the fainter gray grids, then we're good. We can take that as an ordered pair. So looking here, I see this is one flight of stairs, matches with 18 calories. So one flight, 18 calories. You're going to have the 2, the 3, the 4, the 5. Whoa, what number is that? The 5. Let me just redo that. There we go. And you're going to follow them up and record the Y coordinate, the C coordinate, the calories burned for each of them. Write a sentence relating the relationship between the independent and the dependent variables. We did this in lesson 1 last Friday. The blank depends on the blank. You need to fill in the blanks using words from this particular graph. What equation represents the relationship between the independent and the dependent variables? So I can see right here, maybe I should have included it in my table, that my graph passes through the origin. So that's 0.00. That tells me that this is a multiplicative relationship. And fortunately, when I write multiplicative relationships, I'm looking for the unit rate, the 1 something equals this many calories, 1 flight of stairs, and I already have it right here, so I don't need to do any extra math. 1 flight of stairs is 18 calories. That means 2 flights of stairs is double 18, or times 2. 3 flights of stairs is triple 18, 18, 18, 18, 18 times 3. So this is a times 18 relationship. So I'm going to say 18 times F, because that's what they've defined my X value as. We're calling it F for flights of stairs, equals calories burned. If Jada walks up 22 flights of stairs, how many calories will she burn? And then if Jada burns 270 calories, how many flights of stairs will she climb? We're going to use that equation we just wrote for both of these. So I'm just going to rewrite it. Exactly the same, not changing anything yet. Now the number that's in part D, the 22, and the number that's in part E, the 270, I need to be careful and correctly identify, is that my calories? Is that my flights of stairs? Because if I plug that in the wrong spot, I'm going to get the wrong answer. So this is 22 flights. That means that I'm going to replace, or as we call it in math, substitute this variable F with the number of flights I now know it is. And I am still finding calories. On this side, this is 270 calories. I don't need to replace flights with anything because that's what I actually need to figure out. But I am going to replace my calories with what I know I've burned. And now you are going to solve for F. On the back, Hector's family has a box of 25 ice cream cones in their freezer. So far, his family has eaten 9 of them. What decimal represents the part that is still left? So part eaten, part left, total. Oops. Where's my undo button? There it is. Total. The total number of ice creams is 25. The part that has been eaten is 9. What's the part that's left? Well, 25 minus 9 will give you the part that's left. And then you are going to take that number and divide it by the total, because when you divide your fraction, it will make a decimal. So 25 minus 9 is 15, 16. And now you can either do this division or scale this up to be out of 100 and then make that into a decimal that's in the hundreds place. Marcus baked a birthday cake for his best friend, and cut it into 15 pieces. So far, he's served 3 pieces. Which of the following values is not equivalent to the part that he still has left to give? Okay, part served or eaten, part not eaten. Total. Total is 15 pieces. So far, he's served 3 pieces that people ate. What is the number that he has not eaten? 15 minus 3 is 12. 12 is not the answer. We are looking for things that are not the same as 12/15ths, the part out of the total. So maybe you want to make it a percent. Check out if that 80% is true or false. Maybe you want to simplify 12/15ths. Check on that 4/5 versus that 1/5. Maybe you want to divide 12 divided by 15 and check on that 0.8. However you do it, 3 of them are equivalent to this, and you don't want to pick those. You want to pick the one where you're like, that's not right. Again, on these 2, you are watching out for the not, or like which part are we truly talking about? Are we talking about the part correct? Or are we talking about the part incorrect? Make sure you're showing me your work here. And, oh, that was the last section. All right, now we're done with our homework.